everything is started. So we will continue today on our with our project from last time, so our data acquisition example. Right, so let's quickly start it and remind ourselves where we stopped. I think oh, there's a bug somewhere. I think what we are missing mostly is the to finish the saving and loading of the configuration. So we started it very roughly using the QSetting class, which allows us to save and load ini files. But we will need to to also save now the properties that we have not yet saved. Right, and device seem not have to be yet completed. And we need the ID, so let's see. Yeah. So we will just start with this parameter, and for the ID we need to add this to our device class, and I think the most elegant way is to add a pointer on the factory to each object. So this way we can reasonably easy know the ID, and we don't then need like to store the ID twice. So this is I think an elegant approach. So we will have here the name and /amp. And I think we'll have a factory pointer. So you might have noticed that sometimes I add class or struct before the name, or sometimes not. The general idea is that if the type hasn't yet been defined, so it's defined here, then you can use pointers to the type if you just specify if it's a class or a struct without it being defined. So we can also do this here, like this is just an empty definition, and it tells only the compiler there is a type of this name. It doesn't tell it, and it does not tell it anything about its content, but it doesn't need to know anything about the content if it's just supposed to be used as a pointer. So this way we have the luxury of having objects referring each other in a nice way, and we of course need a function to get this. So get factory, thinking if we can make this even more elegant. We can make this even more elegant. We don't need to waste memory on every single one. We can use a, so this stays as is, but this is static. And this will just be also defined as static, then we don't need to pass it as an argument while constructing it. Instead we'll initialize it only once for the whole thing. So, but then this needs to be virtual. Ah, that's a problem. Okay, we can do it like this. This will be virtual, fully virtual, and this will be static, but in every single implementation. So we have our demo device. Let's just put as the last entry. Demo device virtual is not meta. Same for our test device, of course. Test device. is equals but where do we create those factories? That might also be not great. Okay, this needs some minor improvement as well. So we start this as null. We can copy it to the other test device here. We need to set it to a value. So here, let's make this. Okay, we can make demo factor. Oops. So in this case, we assume there only is at any point in time only one factory object in existence. So we can now, when it's instantiated in the constructor, demo device friend class factory, and set this, and we do the same for the other one. So this way we are quite efficient. So because this is static, it's a static variable, so they don't exist in every single instance of CTest device. There's only one shared instance, and since it's shared, we don't waste that much memory. And we just initialize the value here from the constructor. Of course, if you would have an architecture where there might be more factory instances in one process, then this approach would fail. What we can do, if we want to ensure that we are on the safe side, we can use a QAssert. This is a runtime check, which is only built into the program when building in debug mode, and it will pop up a window with an error if this condition is not true. So this is false, this must be null. So an assert always checks for the condition being true, and if it's true, then all is fine, and if the condition is false, then it breaks the program execution and shows an error message. Depending on the implementation, you might have the option to ignore the error, although in practice, most applications which use Windows, when they show a message window from one thread, this starts a message loop at some point. So usually they will then maneuver themselves into inconsistent states. So when you press resume, it will probably crash anyways. So only if you would like have, for example, a console application with one thread and then you get this asset, then you can safely continue. Otherwise, it's a bit more problematic. But this at least ensures that if we would make such a mistake, create two instances of CTest device factory, for example, then and we try to run the application in debug mode, then we will be notified that okay, that's not how we are supposed to use this mechanism. One could, of course, introduce another method where we would create the factories as a soliton. That can also be done. And if we would want to be able to access a factory from multiple places without having like one place where we synchronize, this would be the way to go. But for now, we don't need that approach. So well, we have now the factory which we can get. So we should be able to now here get the ID. So we have device. Get factory, get ID, so we'll get our ID. Then we have to store the parameters. But before we store the parameters, we could test if this works as expected. So we need to find the thing. We had some option or some function to. Did we? No, we did not. Right, factories, device manager. So what we do here is we will get the ID. String ID is equals ini file ini punkt value section plus id as a key to string. And now factory path equals vector. We use the value function instead of the square bracket operator, because the square bracket operator, if it doesn't find an element with a given key, it will create an empty element with that key, because it always returns what we were looking for. The value returns not by reference but by value, hence it can return just null without modifying the map, and we don't want to modify the map if the ID does not exist. So here we'll either get a valid factory or null. So if we didn't get a factory, well, to do a message but we don't ignore it for now, and we just continue. So continue to and try to load the next device. We could actually add here qdebug that we at least know that something went wrong in the debug console. The to do refers to an actual error message that would be usable in a way that the user will be notified that something went wrong. So we could also have here maybe a return value or something. But for now here we will just say that there is an unknown factory ID, and we are done with it, and that's a semicolon. Then we continue. Right, so we have a factory ID, so we have a factory already, even better. So we don't need this. Oops. We create the device using the make, then we load the parameter map, and if we would have them loaded, then we could now if we would have them saved, we could now do init. I mean, we can do init, that is fine. Okay, here we should also add an error message that something went wrong, and that should be continue. Failed to init. Failed to init device ID. We should change this to failed to init name. And then we should just grab, no we can, we have name in section, failed in device. And this new section, because that's a name. Alright, and add device. Why do I have commented this out? Probably because we have not implemented it. So, that should actually be fine. Add device, yeah, this device was not yet defined. So this should already works. So let's try it out. Let's add a few breakpoints, because this, like, it would be yeah, I'm missing something. It would be excruciatingly not fun to have to reconfigure the thing each time we change something in our program. So as soon as possible, we want our programs usually to be able to save their state in a way that allows us to then return to whatever test condition we had as quickly as possible. So we said we just add demo device without anything. That was doing random data, yes. So we stop this, and we have save. So let's save it. Let's see how it was saved. Where did we save it? I guess in the application directory. Yeah. Repository QWT data panel x64 debug devices ini. Okay, it replaced space with a percent encoding. It's not pretty, but for our purposes we will ignore that. We could change this to replace spaces with underscores. That's generally a more elegant approach, but Qt, when implementing their ini file format, they didn't care much about elegance. They wanted just something that works in more or less any condition. So using percent encoded for any character that cannot be easily represented is a good approach. That said, in the section names, I think Windows would handle spaces just fine. So here they really went a bit overboard with escaping everything that's escapable. No, but it is ugly. Let's change this to underscore here and change our code to use section replace space with underscore. When storing and when loading, we need the opposite. Section. Okay, this doesn't need, must not be a reference. So replace, strangely enough, although it returns a reference on itself, it still alters the existing strings. And as you see here, all the replaces give just a reference on the current string, and they are not const. So when we do replace, we actually modify whatever string we did it on, which is a bit counterintuitive. I would usually expect if we have a function that returns something, then it returns a full copy and doesn't modify the original thing. But here, you see it is kind of convenient because you can save a line if you just put it here and then work with the string. Here, since we no longer make this a reference or const, then we should be able to edit it anyways, and then we just swap it the other way around. So now when we go to start it, we will end up here in the load function, and we can see how this works. So we have our section with the underscore. Now we have our section with the space. Wait, that was not smart, because here we still want it to contain the underscore. We need to do it further down. Here we still load everything, then we should do it here. I mean, we could in principle just put it there, and this will already be changed, plus it doesn't really matter how it behaves when we enter when we just display the error message. They should add it to do to also their reported error somehow. Okay, so again we start. Now we still have the underscore, we will keep it for a while, so we can get the factory, which worked just fine. So we have our factory now. Then we load the parameters, which they are none. Oh, sorry, do we have one or do we have none? We only have the ID. So it kind of here will add this ID parameter, and the way we will implement the mechanism if we do something is that we just ignore unknown parameters. So we could of course add here a line that if key is section/ID, then it will continue as well, but it really isn't necessary. So this is fine enough. And then let's just continue the thing, and it didn't work. I guess we need to sync the UI. We forgot to do that. So as you remember, what we have the add device used. Here we had this update devices, and after load we will also need to update devices, otherwise we will not display what we have just loaded. Yep, it's here. It was all the time here, so if we would run it, it would have even worked, but we wouldn't have seen it. It was already running. So now we will want to save the individual parameters, and in principle you could just add dummy functions for now, since we don't use those parameters. So this is we just need this store param function device, and since we don't always use these parameters, what we can do is we could in principle make this a dummy function here, so that qstring reference, so that we don't need to add like empty ones in all the functions which don't care. So it's just a virtual function without a body, and if we want to do something we can, but we don't have to. So for example, I mean we can implement it, let's say, only in one of them in our demo device, and we don't need to implement it in the test device. That is convenient. Of course, this will then, then need a body, and did we save the parameters? We did not. So since, and we should put this below init to have the same consistency, we will want to do something with these params. We could of course store them globally, or we could instead of storing them globally I mean storing them in the prototype C device, we could also store them here locally. I don't think there is a large advantage to either option. So the idea of storing them locally would be that if we would want to save the data in a different format than just a variant map, this would give us the opportunity. On the other hand, it is likely that we will be quite happy with a variant map. So I would say we will, actually what we could do is we could have a generic store parameters that works for all the devices. That's a useful thing. Let's do it this way. So this actually we can remove. We will just add a params variable to our device, abstract device. Just have a name and params, and then just in here we just save both values. Then we can do that for test device, and even test device will be able to save its parameters. Right, because we already have names, that is a nice solution. So this will not be actually empty, it will actually get something to do. And what we also could do is we could add a generic init. This is not the worst strategy, as it allows us to save code later on. So currently the inits are quite identical. When you look here, we just init, and here we also just init, so we can just copy one, put it in a shared place, and when we then really need init, since it's a virtual function, we can always overwrite it, and once it's overwritten, we can add additional initialization. This way it saves us some work, right? So we have this, so now we need the params. So here we are writing to the ini file, or we could make it even more elegant. Instead of having, if we already defined that we want to work with those, we could just add the function get init params. I like this even more. Get init params const, which just returns params. Right, so this makes the whole thing even more elegant. If our init params, then we just need to use it here. Cool. Guys, get init params. Okay, and now we just go through the list. So for auto is equals this. Begin on equals and plus I in set value. We can copy section slash from there plus e punct key. That's already a string and a name, so that should be just fine. Comma, and here e punct value, and value is a variant, and the set value already takes variants, so that's already it. Now, variants can be of types which cannot be saved to an ini, so it will be at this point our responsibility to ensure that we only use compatible types. But this is something we'll notice quickly if we do something wrong. Good. What we also might want to have would be additional properties, which you would then save separately from the parameters. But I think for a simple application, it's enough to have like all the parameters that there might be configurable during the init, and then we can add a window to change some of the parameters later on if we want to, and if we deem that supported. But we will not need to have like init params and separate some runtime params or something. And if we decide we want it, then we can always add it using a similar method that what we did here. So since this will not make much of a difference, although we could just for funsies run it and see how this works. So we just close it. That should add an empty string. It did not work. Why? Because we initialized it. No. So here, let's remove that again. The thing is, if we start with an invalid value, then of course we won't get the right value, and we can add here test or something. And now if we close it, then it should be saved properly. Yeah. Yeah, we called the parameter 1, so it's 1, but we could have given it a nicer name. So as you remember, in our demo device header here, we can set IDs, so we could really name it like something that makes more sense than just one that's more intelligible than just a simple number. Okay, so we have this now in a state where it works nice. We could maybe add a second device. S2. We didn't want both to be red. We don't have a color picker yet. So it's yeah. We should also add some more randomization because this is not nice. So where were we? Demo device, yes. Thread, and here we are using this rand function, but this has like a state per thread, so we should somehow initialize this nicely. Yes, around getting count. So this can we get the current thread ID? Yes, we can. This is defined as it should be actually available on our current object because we are of the type thread. That's the type handle. Then we need to cast this to. Okay. So this will ensure that each of the instances will start with our own seed, so each of them will create other random numbers. Currently it really worked like they were repeating the same random in quotation marks pattern, because this random function it is fully deterministic. It just looks random if you don't know the starting condition, but if you don't initialize the starting condition, just starts with the same defined value. So now what we do is we are taking the runtime of the system in milliseconds since power up and XOR it with the thread ID, such that we get something that is reasonably unpredictable. Now we of course will want to do something with the colors, that if we add devices that they will by default have different colors, since the color picker is a to-do, so we cannot rely on it being ready anytime soon. What was the data panel? Red. Device channel count, right? This is of course not good because it starts at the same value, so we will make a counter. We'll make just counter channel E. This is correct. So at this point we can plus it. So we'll also change the types here. So why not? Right, I want to add a second one. If we don't close the program gracefully, then it of course forgets whatever configuration was set. And now, as you see, we get different colors and different random values. You can add another one. And it adds another color. Okay, blue on this background is not very visible, but it's there. So as we see, this works quite nice. So let's stop, clear, play again, stop. Okay, so we are so far that it looks quite nicely, and we have some dummy devices which are just for demo purposes. So what we now could do is to create some more complex devices that will retrieve some data from somewhere. For example, we could use a network protocol to connect to a second program that we will start, and whenever we connect and send the right command, we will start receiving data which we will then be plotting here. And for this we will also really need to use the parameters which we can configure, because then we would for example need to specify the IP address and the port, or if we are using a pipe, then they specify the pipe name, or if we are using a serial port, although here we will not, since we don't have a physical device connected to the virtual machine. I mean, we could, if there is a lot of interest, I could set up a demo, but you need to request this upfront. We could either just connect two virtual machines with pipes to each other over COM port. So basically the virtual machine runs, it has a virtual COM port inside, which the VMware translates into a pipe on the host, which then gets plugged into another serial port in another virtual machine. This is quite nice, by the way. You can use such things to debug the Windows kernel if you are writing your own drivers and don't want to use a physical machine for debugging. Then you can just run a VM, connect the serial port to a pipe, and then connect your kernel debugger to that pipe. So this is quite nice. But I said that needs some preparation, and a COM port, a physical COM port, would need, of course, the port name, baud rate, stop bits, and parity. And if we are using a pipe, then those physical parameters are not really relevant, and because when it's translated to the pipe, it just puts the content. There is no baud rate, there are no stop bits, etc. So if we do such a demo, we could add those parameters for completeness, but they would not break the demo if we set them incorrectly. Only the port name would be relevant. Well, here when using, for example, network, we need IP and port. What we could also add is we could make a multi-protocol plugin such that we can select IP, port, and protocol type, so that we have like active selection between TCP and UDP. Although in this case, it probably would be better to have just independent plugins. And yeah, and what we'll also need to do at some point will be to add a window that if we double click on it on the device, it will actually give us the window, or a window similar to this one, with all the parameters. So without the first row, of course, but only with the parameters, so that we can update them. But this is something for later. Okay, so let's proceed with implementing such a network device. Devices add class. Yeah, we need to decide whether we want like one device that can do multi-protocol, or if we want one device per protocol. Let's go with one device per protocol. I think this is more elegant. So this will be a TCP device. For the file names, we don't want the space class SC device, and as usually it will create the files filtered where we don't want them, so remove them to a device filter. Okay, and we can go to a test device and just copy it. Just replace all occurrences, and then we do the same in the CPP file. Although that one is so simple that we could do it by hand. To get this replace window, we press the Ctrl H hotkey. Okay, and now let's see what we will need as parameters. So first will be of course the IP. So IP field 1. The name here doesn't matter, so we can leave it as this. The second one will be the port. And for the name we'll take TCP port so that it's clear what the thing is doing. And the third one doesn't exist, so we only have two parameters. Of course here the ID will be TCP device, and here will be TCP TCP network logger. That's a nice name. Okay, factory is ready. So it doesn't do anything yet, obviously, but it already is. Oh, and we need to add it, of course. But it already has like its very most basic definitions. Hash include TCP device. It already added those TCP device, and here just did I capitalize this or not? Probably not. I did not. PTCP or TCP netlog. Doesn't really matter, but it's nice to have nice names. Of course, we could add a function which just implements this row so that the whole thing is a one-liner. Maybe we should add this. This makes the code nicer. Protected. Void add factory. It often appears like it's a waste of time to do such things, but once you have like 100 devices, then it will actually be a big help to only need one line per device to add a new device. So such seemingly minor improvements are always worth doing already from the get-go, because once you already started, you have a large amount of code which works differently, is less elegant, then it's more work to fix everything later on. So now we should be able to add the device, TCP netlogger and IP 127.0.0.1, and port, let's go with 1234. And it won't do anything yet, but it is already here, and if we close it, then it should be saved into our device file. Yep. And what we also could improve about the mechanism, when we go again to a device definition, here we have like info, ID, label, hint, and nothing more. We could add a default value, because for example, for our test cases, we'll always use the IP 127.0.0.1 because we just do everything on the local host. So this would be something that is for us useful. If you have other devices, for example, coming back to our serial port example, usually the serial protocol is device specific, so we will not have like one serial device plugin. You will have like one serial device plugin for one device, another plugin for another device, yet another plugin for yet another device, and so on. So, and all those devices, if they use physical or USB emulated serial ports, they will require, in case of USB, it depends on how it's implemented. In some cases it requires the baud rate to be correct, in other cases it does not. The difference basically is whether the serial port is emulated directly inside the IC which does the data processing, or whether you have really like an IC that creates serial data, and then the serial data are processed by another IC and which is just a serial emulator. So in the later case, since you have actual serial data existing physically on the PCB, you need to have the right baud rate. If it's fully emulated, then you don't. But in any case, it would be, for example, good for your devices to always have the default data rate of the device set as a default value in your UI, so that you don't need each time to look up which serial rate which device used. Same for parity, stop bits, etc. The only thing that will change reasonably often will be the COM port when you are plugging it somewhere else or so. And to note here, of course, is that many devices offer you the option to change the baud rate in their UI, which of course is something one might do, but usually you just leave it at whatever was the default. There usually are no pressing reasons to change from the defaults to something else. So here we will have a default field with which we will pre-populate our text, set text, and it might, and the thing is, if we have a default value, then we will not see the hint until we delete the text, but if default is null, then the hint will still be visible, so this is fine, and we'll only use this in our TCP device plugin. In principle, it would be elegant to have this thing further down, and also make a function that allows us to make this to be one-liners. But for now, maybe leave this as is. Default is just equals 127001. And the port we will not make default, but for the port we could make a hint, which we suggest to use 1, 2, 3, 4. Okay, and now when we run it again and try adding a second instance of the same device, we have one value already. Oh, the hint doesn't work. Sure, it doesn't work. I have a typo here. That should be, of course. Okay, and you see, if we are copying and pasting a lot, such errors can happen. If we would have a function that does this for us, we wouldn't mess up the numbering and have a problem. Now we have the hint here, and as soon as we start typing, the hint disappears. For this, we actually could also add a hint if we want, but let's not do that. And since we already ran into this error here, let's maybe indeed make here a function for this. So since we have here fields in our factory, we make a void add field. What does it need? Well, it needs all those things, obviously. And once we add more thingies, then we will right, so default should be qvariant, because we might later on have different types than only those. So for hint, I would always leave it, I think, as a text, but we need to quickly fix the thing, since punct default cannot be set as text. Now we need to use punct default punct to string, and this works if it's a number or many things. So Qt can convert all the types which can have a string representation. It is complaining. Right, we are not ready with our function, that's why it's complaining. Yeah. And for reasons of doing things the proper way, we will implement the body in the CPP file as it should be. one demo piece here. So this will only be called field without anything. Oh wait, the device is not right. We need the factory. Field append field. So ID label hint and default. Okay, so now we can use the function. Let's ignore test device. Let's just do it here in our where we want to do something. So we have IP, comma IP address. We said no hint, so empty string and oops. I don't like the Visual Studio's new behavior that if you mark something and start typing something that could contain it in a string, that it automatically thinks you want to make something into a string, because that's usually not what I want. Usually I just want to delete it, so that's getting mildly annoying. I'm sure this behavior can be somewhere disabled, but Visual Studio has so many settings that finding them is a large chore. Right, hint and no, alright, and we should also add a default parameter for the default value that we don't want to specify a default value. So default value can be null, and hint will also say that it can be empty. Okay. Alright. Also we have our TCP device. There's a comma missing here, and let's maybe move this into the CPP file as well. That is appropriate, and we should add some separator. So we had here in our test device, demo device, separate. Oops. The only reason why I'm copying it is because I want the same amount of backslashes be always, so that it looks nice. Although here it is still complaining to the argument. Oh, there's another typo. Now it's fine. Okay. Good. We could improve this. We could reduce this one line, but by implementing a template. Why not? Let's do all the tricks in the book. So we have here our device factory, and then we have a template t device factory template device from device factory, and new device pointer new t, and this should be an override. TCP device here, and this is then derived from this, and as a template we provide the TCP device. So we save a bit code, not much. Oh, we forgot one thing that needs to be public. Otherwise we cannot access it. Okay. Right, and we can, I mean, here we since we did this, then we don't need that. This we will leave as is. Demo device, we can do the same thing. Oops. Of course with a different device type. This can go away, and our TCP device where we started the whole shebang also needs this update. Yeah, and we can really not make it even smaller because the names we need, the types here we need as well, so this is as elegant as this will get. Okay, so let's start creating some remote device to which we will connect. So what we will create will be just a new project. Actually, we can do this here. I can add a project, and let's go with let's go with a Qt console application. That sounds reasonable enough, so we will call this so CLI means command line data generator. As good a name as any other. We need to add the network component. Finish. So I don't think we can easily make Visual Studio start the thing, so we'll need to start it. So we can set a dependency that it will always be built. Great, something saying. We can set a dependency that it will always be built, but we will need to start it manually, or we will need to make our application start this thing, which we could do. It wouldn't be very elegant, but for demo purposes, why not? I think Visual Studio just crashed, so let's just restart it and see if we forgot to save something or not. Demo device. Well, at least okay, it did not. We created the new project, so the only thing that wasn't saved was the solution file, but the data files were saved. So we can now just add existing project. Where were we? QWT data panel, CLE data again. Okay, so we have it added again. Let's save now. Properties. Now it works for whatever reason. Project dependencies. Yeah, and data panel is dependent on CLE data again. So when we build this, it first builds the CLI data again, and it puts everything in the same output. So here now we have both programs, and then we can start the thing. We cannot. We can set the Qt path, which contains the necessary libraries, to be part of the default Windows path. Then we can start it. Of course, as soon as we have more than one version of Qt installed in the system, this becomes a bit of a non-solution, since we only can use one Qt in our path. Then we would need to create a link to start and change the working directory or something like that. So as you see, it works. We can stop it. In principle, even when we start it like this, we can attach to it. So so we can debug it even if we start it not from within the debugger. And yeah, and I think for now we will go with a very simple mechanism. It will just print lines of text so that we can test whether it works. So we can change the startup project here, that now this thing is starts automatically instead of our UI, as long as we are debugging it. And I just want to see if we have the right file here. Nope. Then we need to copy a few files over. We can use either putty, or we can use a telnet. I thought I copied that over already, but well, now we have it, and it's quite nice. So let's go to The stupid Windows 11. I don't want this modern shell. I just want a Einstellungen. We want just a normal shell. Why would people want this garbage of a PowerShell? That's so annoying. Right, cd telnet 127.0.0.1.1.2.3.4, and we could connect if it would be running and if it would have an implementation. For now it does not, but the idea is that once we are done with the implementation, we can just here connect and the thing will just start posting random numbers to the console, and at this point we know we can start implementing the device client side. Okay, so we are here, we have our main thread. We will need some main objects, so let's create a class. Add new class. See, what was the name of the thing? Of the data again. We didn't add TCP to the name. Well, now it's too late. We will continue as this. We will just make a data again class, and a base class is Q. Let's think of it. We could run it in an own thread, or we could run it the main thread. If we don't generate too many data, it could run from the main thread. So let's try to keep it simple. So let's go with just a Q object. Object. I think this is free of typos. The file name should just be data again. Now let's add TCP to the name. Even if we forgot to make give the right name to our project, let's at least give the right name to the file, because later we might implement a UDP again. Actually, we could maybe use the same project and just have different generators initialized depending on which command line argument we pass to it. So this actually maybe be fine to be one project. Okay, so here we have our object. And since for now we of course don't have many different ones, we can just instantiate this thing. Hash include TCP data again. Right, so the thing will be instantiated, it will do its thing, and then once this runs, we have our event loop operating. So we will need the network stuff. Hash include QTCP server. I do not remember whether it contains QTCP socket or whether we need to include that extra, but let's just include it just in case. QTCP socket, and we are on the safe side with everything we need. Public Q object public Q object. Right, this we will do in our source file here. Q object suck parent. Oh, I forgot the asterisk, that's why it's complaining. Right, so we have the thing, and we will clients is easy, but we need a timer. So let's first start with this. So we already know how to create timers. We can copy it from here, just those two lines, and then the other ones from the header, and maybe make here also a new filter core, so that we have the two files close together. Right, yo. So we need this line, and we need those two lines, and we need those piece of code. So, and we need to add a destructor as well to the whole thing. Right, that might of course be a problem. Do we have a timer on this? Start timer, stop timer, kill timer. We have a timer event, but we don't know what the timer event is. Okay, so right, we're not together. Start the timer, kill the timer, and hash include q timer. Nope. Qt has files for this q timer, but we may also need to actually put this in the header here. Yeah, now we have everything we need. Let's put a breakpoint here just to see whether our timer is actually running. Oh, we have a bug somewhere. Oh, is that still active? Yeah, we did not stop it. Yeah, our timer is timing. So let's continue. Now we will need a TCP server. TCP server asterisk null, and we need some clients, so q list. No. We can either make a map with q TCP clients, or we can just make a list. Let's go with a map. Q map q TCP socket, and we can associate some data with that. Whether we need this is another story, but for now let's create a struct as TCP client, which does not contain anything for now, but we will just like to have it. And also this should be a pointer, and this let's go with a pointer as well. MP clients. Okay, so we have our server, we have our clients. So now it's time to remember how to do the rest. So we just open one of our existing projects, qtcp server, and copy some code. So it's always useful to not have to retype everything again and again. So we need a on new connection, on disconnect, and we don't need on data, but we'll add this still because it's nice to have. Right, so on new connection, data on disconnect, so we copy everything. Oops. We paste it here. This part needs to go into the constructor. So we create so MP server. Did I not call it MP server? I called it TCP server. Okay, let's stick to that name. Let's just call it server. We will not have a different server inside the TCP class. So connect new connection. We listen on port. We said 1234 is our default. We could later change this such that we can provide a command line argument to change the port, to change the default port. So we get the connection, we connect on data and on disconnect, then we add our entry to clients, and clients get socket plus new as TCP. Now that I think about it, there is no need of calling it a TCP client, we just call it a client. Because as mentioned, inside this class we will only have a client. If we would ever create a UDP server or a custom protocol server, we would then have an own class to contain it with an own namespace. Okay, so sender goes on socket. Well, on data we don't care for much. We don't want an echo, we just want to debug print if something would come in. for later application, and of course remove is similar, so we will just delete clients, take socket and socket delete later. So the container types that Qt provides, like QMap, QList, QArray, QVector, are much more convenient than the standard STL container. So for example, the STL container does not have a take function. And with an STL container, you would need to use add to get the element, or find to get its iterator, and then you could delete it with arrays, but that would already be like at least 3 lines, because first you have to find and you have to check whether the return is not end, then you can delete, and then you would need one more line to erase, so it would be a 4-liner, while here it's a 1-liner. The nice thing about take is it will return a null if it cannot find whatever we requested, and the null operator is defined such that you are allowed to pass null to it. So if it sees it got a null, it doesn't do anything. So this is quite nice. So the only thing we need to do here in our timer is to have a loop for each. Let's go with a range loop for auto e double point. Where is it? Clients e hello. Okay, IntelliSense is broken. That's annoying. I think it was key. Right. Let's see. It might also not work. We can do this manually. Auto e clients begin. I'm not sure what sort of iterator is used for the range loops of the Qt object, but when you do it manually, it works just fine. Or not? Did I forget something? That was the problem probably all along. I changed the name without changing the word. Yeah, we allow it. And now if we connect, we already get test, which is a success. Oh, and we cannot break out of that. So if I press Control C, it gives us, it just sends this character since it's a telnet, and escape is \b. So we actually should use our onData and to see if we get any of those characters, and then break out of them. Just copy this to a notepad. Oops. So that we know what characters we have, and when we close this, then the connection of course breaks, but we will actually want to be able in the debug case to break out of that. So if this is the worst way of doing it, but it will work. If it contains this character, does this work? Okay, we can also make 0x3. Then socket disconnect from host, because the normal disconnect is for the signals and slots. So this is less than great. Okay, and we should do it for the other one as well. The other one is escape, I think. One was Control C and the other one is escape. Okay, so we can run it again. And if I press escape, we are out. Nice. With Control C it would also work. Okay. Right, so we just now want to feed random data to the thing, and we of course need to initialize our rand function, as you might remember from our colors. demo device already had here a nice rand initializer, so let's just do it here in the main function. Right. I hope that's a static function. If not, then it looks like it's static. Well, it doesn't complain here, so it will work. So it should be. It says static inline. Nice. So we can always retrieve the right name. And here for the data, we want this to be a text-based protocol, so we will not send the raw stuff, but we will I put it in the wrong project. Oops. We can close this project since we don't need anything from it anymore. Right, here we wanted this to go. And instead of test, we will generate a string. So q string number from rand plus \n. Or we go with the Windows version \r\n. And this needs to be cast to a to Latin 1, so that we have a something that can be written onto the socket. Right, we can just make one more test. Or not. Oh, we don't have get tick count. This is okay. We have two things. So first of all, hash include. We need a thread for this, and for tick count, hash include Windows H. Okay. Maybe we should go with a Qt only solution for the get tick count, but for now this is fine as is. Yeah, nice. Yeah, let's go with a Qt only solution. Right, and this will be actually even better, because then we can use a 64-bit number. Q data time, which is also not defined. The thing is, when you use a Qt GUI project, you get a lot of things already included by default. But current date UTC to to msec since epoch. Right. Okay, let's move this to our demo device here, so that we don't need the Windows include. Where did we have our Windows include? We didn't have a Windows include. Nice. As mentioned, you get a lot of things included automatically, including apparently some Windows headers when you have this whole GUI thing. This is well, it's almost good. The srand still only takes an integer. We could improve this even more. QUint64 seed. So the thing is, this thing takes a 32-bit integer, while time since epoch is a 64-bit integer, and qthread is a handle which is a void asterisk, which on a 64-bit platform is also 64-bit. Let's be consistent, this is a signed, and this is also signed, so let's go with QInt64 and here as well. So what we'll do is we'll have seed to QInt32, or you just could use int, that's also fine. Then XOR with int seed shift 32. So what we do here is we do the logical XOR operation bitwise with of the lower half with the higher half of our 64-bit number, which will give us an even more mixed up 64-bit 32-bit number as a result. So this is the most elegant way we can do that given our current situation. We could of course try to add more randomness, so we could not only use the current thread, but we could try to maybe use also the current process ID, or just read some random memory address. For example, take the current stack position and things like this. But for any practical intents of purpose, as long as you are not creating a key material for cryptographic operations, this level of randomness is more than good enough. Okay, so right here. So our thing is done. Let's just compile it again. Build. Once we are done, we can switch here to this being the main project. Now we can start this manually. So this will just always run in the background. This we don't need. We can test it again. So see, it works fine. And it just keeps running, and now we can implement our device so that we have it. Now it might appear a bit boring if you always just pull random data, so maybe we could later modify one of the devices to generate a sine wave or something like that. Also, the next thing we will change is that we will not only transfer the value, but also a timestamp. For now, for the first implementation, we'll just take the timestamp when we retrieve it. But generally, if you want to have good correlation of your data, you would try to have some common time base amongst all your devices, and then, when possible, supply them with a shared time signal, shared clock. This is especially needed if you are doing things over network, since there you might have significant delays. If you are reading things from a serial port, it will be more or less instantaneous. So you can assume that if you are receiving the data from some device over serial and the device doesn't give you a timestamp, that's not a big problem, since you will just timestamp it as soon as you read it, and the jitter there should be within a few microseconds. If you use high performance counters on Windows, and if you don't, then it will be still in just a few milliseconds, which, depending on what you are doing, might be good enough. Another approach there is, of course, to not rely on timing, but rather like have some experiment procedure control that you really like, say, stop data acquisition, change configuration, start experiment, wait 5 seconds for everything to stabilize, and then resume data acquisition. Then you would always know that the data you are receiving belong to the right configuration of an experiment that you want to monitor. Okay, where were we? So our TCP device will need many things actually. Let's see what we can do. So here we have our start, stop, and reset. So we will definitely need those. We already have stop. Reset we don't care for that much, although we could go with the demo device. We will not need a timer, since we don't use a thread. We'll go over network, but we will have those two, and we will copy the reset thingy. Actually, we can take more from here. We could take as much as this. Okay, so start, stop, we will implement. These are the templates. This we don't need. Lock we don't need, because it will be one thread. The position where the friend is doesn't really matter. We can put it everywhere. It's just customary to put the friend definitions below protected, but since this is only relevant for this one class here, let's go. Let's place it as is. Right. So here we do not lock, and what we will need will be our socket. So and we need to include that hash include qtcp socket, qtcp socket, ampersand socket, and this is a pattern. Okay, so TCP socket, new TCP socket this. We just initialized, we don't do anything, but we will need to connect two signals, those two signals. We can connect them instantly, so we don't need to slots. Private slots, not signals. Oops. Okay. And we also will need to have those functions so that we can copy at least partially from our demo device. Well, it's almost not worth copying, to be honest. That was before this. I mean, start we need to fully implement, stop we need to fully implement, and only reset can be left as is. Okay. Now on disconnect we might decide not to do anything later. Let's say that to do show saga on connection lost, so that if we would lose the connection during the data acquisition, that we will display to the user or notify the user somehow that this happened. And here in on data, alright, before we do that, let's fix this one. We could also add like a on connect slot so that we know whether the connection was successful. And we might want to actually lock start until the connection was established. So this, let's first implement this here. Actually we can copy this line, two lines actually, these two lines. Now here we either use psocket based on sender, or we use our own psocket. So actually what we could do here is we could have, if for whatever reason they are not equal, I mean in our case here this should not happen, this cannot happen, but we can add this. So for example we could actually maybe we will do it this way. So we will leave this as null and we will only connect and initialize it on start, and then on disconnect we will at least disconnect those two. So now the disconnect has a purpose, and let's get rid of the socket if this happens. So on disconnect, just to have a test here that this is fine, and then delete later, and is equals null ptr. So when if we lose the socket, we dispose of it, and then we only create it in here, and actually stop will be only disconnect from host, but only if it's connected. We could return an error if it's not connected, but I think it's better for us if we just ignore that case. So we just always say, okay, stop was successful, and this stays as is. So now we right, and start of course needs a check. So if this exists, then return error. I don't remember the error. Already running. Already running, because we don't want to do this twice. So we have this, we connect things, then we connect to host, and now we need the address. So host IP, we can get it from params. We just need to look up the name, so it's called just IP, okay. To string ups to string, Okay. And we need the port. So q u int 16 port is equals 2 short. Should be 2 short, don't I have 2 short? 2. Okay, old versions of Qt had this. We could go with uint, but we don't have a... Okay, they don't support shorter types than int, so let's go with 2ulong, and then we just cast to the shorter type to avoid a warning from the compiler. Okay, now connect to host, and then can add here a wait for connected, and we will wait, let's say, that's too long, just 3 seconds, so 1 0 less. And actually this should give us true or false. Yeah, so let's do it like this. If it's false, oops, then we will do something else, and if it's only do this if it's successful. Right, so on connect, and if it was failed, then this delete latent is equals ptr, and turn some sort of error message. Error, connection failed. -4. Right, nice. Okay. So at this point it should connect, and once it's connected we should start getting data here. Q block. Okay, let's test it before we actually do something with the data, just to see whether this is working. You should have added here a client connected, client disconnected message, and so on. Right, so just play output, and we are getting data here. So the other one is not yet plotting anything because it's not fully implemented. So let's demo data, this thing. Yeah, we stick at the rand designation. Okay, so it might be very, what's the English word? Verlockend, tempting to just handle here what we get from the socket, but we must remember that this is a TCP socket. So while in this particular case we got the data in individual packets because there were no delays and they were sent slowly, it can easily happen that 2 of those packets will be bunched together, or 100 of those will be bunched together if there was a connection, intermittent connection failure on the other end. And then it might even be that we have more data in the send buffer than what fits into one TCP Ethernet frame, so then it would be broken up somewhere in the middle of a value, and so on. So always when using data from a streaming source, we need to have a stream buffer. So we'll implement this here. Q array buffer, and just some sanity checks. So when we start connect here, before we can clear the buffer in case there are some garbage data from the previous attempt inside, so that we know that we always start with a clean slate. And then we will this we can comment out, append to our buffer the data, and now we will be always processing the buffer's content, even though it's likely that it will work out fine. In our case, we need to always make sure that our programs work also in edge cases. So we have a loop which will processing the buffer, int pos, and we are looking for line breaks. Pos buffer.find. Or was it index of? Index of. And we are looking just for one character. \n. We are not looking for \r/n. We could do that, but it is a better approach to just look for \n, then check if it is preceded by \r, and then ignore the \r, because this way this way our implementation will be independent from whichever line break convention the sending side chose to use. So this is a generally good approach. So of course now we check whether we found it. So if this is -1, then we just break, and if it is not -1, then we do additional checks. So int. So first of all, we check whether this is 0, because if this is 0, if pos 0, then we just continue. Well, we cannot continue. If this is 0, then we just remove 1. It might be that for some reason we got a couple \n sent, and then we don't want to get into trouble, so we want to always be as fail-safe as possible. So erase can be used. We can specify, was it remove? I think it was remove. Index 0, count 1. So we just remove 1, and then we continue. The next thing we do is we check. So now we know that it's not -1 and not 0. So we know that this is a positive number. And if we know that, we can check which character precedes this directly. But before we do that, we'll add here a int and a copy of position, because we need the copy. Right. So buffer at end -1. If this is equals \r, then and minus equals 1. Okay, now we have handled the case when there is like no data. We handled the case when there is just an own \n. Now we have this scenario here. What we should do is we should again test whether position would give us nothing, because that could also happen. So end could now be pointing at 0. So we can repeat that test. Does not look the most effective, efficient, the most elegant. Let's think if we can do it better. And of course here we would then need to remove until pos. +1. Right, can we make this somehow more elegant? We could make this more elegant, so we can combine this here. So if this is greater than 0, and this, then we go by -1, and if end is 0, then we just pass +1 and continue. This is more elegant. Nice. Now we can add actually the line. So a q line is equals punkt left end, and then we can remove the data as well from the buffer already until pos. We are using here pos not end because there might be a discrepancy of 1 because of the \r, because we don't want \r in our line. Okay, so at this point we can test whether this works fine. So q debug line. Let's run it. And let's start it. Yeah, it seems it's working correctly. Okay, so now we can fill in the data. So we go to our demo device, thread, and just here oops, that's too much. Line to int. Okay, let's run it. And we have two different values. Now we can also test this. Usually if you select something to mark something, in some interfaces it breaks, but here it doesn't. Interesting. We can also stop this. From here we can just suspend the other process. Where is it? This one. Suspend. And now you see there is only the red line. The other one does not generate data. And if we resume it, we just have like one line going from the last value to the new last value, and then it continues as before. And of course we can stop, clear, run again. Yeah, works fine. Well, that's in a third box. Let's see where we... You were not supposed to press reset. While the whole thing was running. Data panel on reset. Okay, it is a bit more broken because it wanted to show us a critical message box, but then what it did was it went into the exec loop, and then it started executing the next the rest of the operations. So I think what we should do is we should add a safeguard that we cannot cause such an error. On reset chance, yeah, reset device. So here we need to check. We don't have an is running. Oh, we don't. Then we need to add it. Device manager. Start devices, stop devices, state. We have state. Okay, we can use get state. Get state. So if get state is unequals stopped, then we will return an error message. So if this is unequal stopped, then we for a critical message box. Data cannot be reset during while acquisition is running, something like that. Good. That fixed that. This thing is still working, so it was not affected by our application here crashing. That's a nice thing about having independent processes, that if one thing breaks, it does not take everything else down. Okay. Good. So now we get a nice error message instead of something crashing. Okay, is everything clear so far? Any questions? Okay, if there are no questions, then we could look what you would want to do next. And I think, as I mentioned, there are two things we need. One is the handling for the double click. We already have here a handler, but we have seen that it is also expanding the group elements. When we run it again and we double click, you see it's also expanding, so this is not necessarily what we want. And there is a function which we can use to disable this behavior. Where's our tree? Tree, yeah. What was it? Set, expand, and double click false. So this is gone, and now put a breakpoint here. And now when we double click, we go in this breakpoint, but we not change the tree layout. So there will be some new homework here. What's today? 14, 11, 2024. Okay. I think this should be easy enough. It is just a creative application of copy and paste with the existing mechanism for adding devices and listing properties. Of course, it will need some adaptation because you will want to use the actual values from the params variable and not the default values. But the hints and the labels and everything else you can keep from the data that you get from the factory, since we already now have a function to retrieve data, to retrieve the factory from the device. This should be easy enough as well. The only thing that will be missing is a mechanism to set the new params, and there you can go one of two approaches. One is you could track the changes and have like a set and maybe a get function. Yeah, just a set function would be enough for every single param. Or what you also could do is you just implement a global set params function. Although that would be a bit redundant with the initialization. So let's do that quickly. So we have, when we go to the devices, we have get init params. We'll change this to just get params. We'll add a set params function. Const reference. This of course is no longer const. And what we can do here in the init, which takes params, we can here just set params. Okay, this is probably elegant enough. We could and we should make it such that we can define certain fields as only settable during initialization. So when we overwrite init, we have the liberty not to call a set param, but and just the set name on our own. So that we could have parameters which can only be defined once, but I don't think we will have those. But the option is there, so we could add an additional field here if you want, to indicate that a certain value can only be changed from the create device window, but not from the edit device properties window. And this we would like to have implemented such that we still can view the parameter, but it is rendered read-only. So here would be for init only, and of course other things would need to be adapted accordingly. So we will add this as an optional part of the homework. Optional optional enable and fields from being changed after the fields would be still there in the device property window should be disabled or read only. It's actually a difference whether it's disabled or if it's read only. For many controls where you can edit inside, like a text box for example, you can set it either to be read only, which means it looks normally but it just doesn't allow you to change the text, or you can set it disabled, which gives it this grayish look. So disable, do we have an example here? We don't. I can force that just to demo it. Add on a device here, edit, set enabled false. Yeah, we changed the name to get palms only. If we select the device, then you see it's no longer, it doesn't have longer a white background. The text is still black, but the background is grayish. So and in both cases you cannot edit them in this state. So whether we should remove this, that they are disabled or set read only is different. So maybe let's try to be consistent here. So here we said that the should be rendered read only. So here let's say they should be disabled, as this includes read only, and this will give us a nice optical distinction between fields which cannot be yet changed because the acquisition is running, but if we stop we could change it, and the situation where the field cannot be changed once it was already initialized. I don't think realistically there would be such parameters that you would never allow to change again, but it's a nice exercise. Okay, I think at this point we only have little time left, so if there are no more questions we could end this time a few minutes early, since I think it's not a good idea to start something completely different in the last few minutes. I think during the next lecture we might, for completeness, either change one of the devices to generate some more interesting test data, or we will add more protocols like a pipe. Wait, there is actually one thing we could do now before we finish. That is to add the timestamping on the sender side. This is reasonably quick to do, so maybe we should do that. And it will add, I think, some robustness to our protocol. So we just grab this, go to our data again, and here we just write qstring number plus comma qdate is missing, I guess. We are 1 comma short. 2 Latin 1. And let's now go. So this we need to first we need to close this. We close one too much. But that's not so important. Okay, so this was built, then we can start it. Okay, and let's go to here, here, and now we just need to split the line. So we'll make aq list line being a curious, and here split by comma. Then we'll do a sanity check. So if line punct size is greater equals 2, or rather if it's less than 2, then we just ignore the line. And line 0, line 0, 2 long, and line 1 is our actual line. Yeah, this is a small yet nice improvement. Let's see if it works. Yeah, it's working. We don't really see the effect. Yeah, we cannot easily demonstrate that this is actually an improvement, but as mentioned, if there would be some delays on the network, then this would be quite helpful. What one could of course try is to create like to go over a real network and then just unplug the cable and plug it back in, but I don't think this is interesting enough to merit a demo. So are there any questions? No questions? Okay, so in this case I think we will finish with this. I will upload the recording and the project and the homework to the Moodle, and we will see each other next week. Have a nice weekend. Bye bye.